China's first nuclear supercarrier just shocked analysts. Not because Beijing held a ceremony, not because state media made a dramatic announcement, but because, in late 2025, satellite imagery from a shipyard in Dalian forced defense observers to reconsider something they assumed was still a decade away. The timeline just moved. During closed briefings in Washington and Tokyo, one detail kept surfacing: the hull length, over 1,050 feet, and inside that hull, structural features that did not belong on a conventional ship. Features that belong on one kind of ship. For decades, nuclear-powered supercarriers were treated as an American monopoly. 11 in service. Decades of doctrine built around them. No serious peer competitor operating one. That assumption is now under pressure. So when analysts stopped debating whether China could build one, and started debating whether it already was, something shifted. Urgently, quietly, faster than anyone predicted. Visible steel is not proof of a reactor. Scale alone does not equal nuclear propulsion. Not yet. So what exactly changed the tone from skepticism to alarm? To answer that, we need to focus on one thing. Not the air wing, not the politics, not the symbolism, the reactor. Because this entire story, the shock, the alarm, the strategic consequences, comes down to one question. What is powering that ship? The answer does not just change a technical specification. It changes everything that ship can do, where it can go, how long it can stay, and what that means for every Navy watching from the outside. The first shift did not come from Beijing. It came from pixels. In late 2025, commercial satellite imagery of the Dalian shipyard began circulating among defense analysts. At first glance, another large hull under modular construction. Dalian had done this before. It refurbished Liaoning. It built Shandong. Nothing unusual, until the measurements came in. The visible hull section exceeded 320 meters. That puts it past 1,050 feet. For comparison, China's newest carrier Fujian measures roughly 1,036 feet. The US Gerald R. Ford stretches just over 1,100 feet. This was not incremental growth. This was supercarrier scale. Displacement estimates followed. Based on hull length, beam proportions, and deck footprint, open source assessments clustered between 105,000 and 110,000 tons full load. At that size, you are no longer building a regional prestige platform. You are building something designed to generate sustained air power, far from home, for extended periods. Sustained, extended. Those two words are where the propulsion question begins. But then the number inflated. Online forums pushed 120,000 tons. Headlines echoed it. A carrier larger than anything the United States operates. And that is where serious analysts slowed down. Because the math did not support 120,000 tons. Conservative assessment stayed in the 105 to 110,000 ton range. If the tonnage was being exaggerated publicly, was the nuclear claim also being exaggerated? Hype erodes credibility. And in defense analysis, credibility is everything. So observers went back to what could be measured. Length, beam, deck configuration. Catapult trenches visible in early module construction. Those things do not lie. And what those measurements confirmed. Even at 105,000 tons, this ship enters the same weight class as American nuclear supercarriers. That alone does not prove nuclear propulsion. But it removes one assumption. China is no longer building carriers to experiment. It is building carriers to compete at scale. And at that scale, conventional power begins to impose hard limits. Limits on endurance. Limits on electrical output. Limits on sustained sortie generation. In plain terms, a conventionally powered ship this size can go far, but it cannot stay. Which brings us to the structural details that made analysts stop dismissing the nuclear possibility. And that is where the imagery becomes far more interesting. Once the hull dimensions were confirmed, attention shifted inward. Because size alone does not prove propulsion. What analysts found next was something else entirely. High-resolution satellite imagery revealed unusual structures inside the central hull sections. Massive internal blocks. Not empty compartments. Not standard machinery spacing. Dense, reinforced volumes positioned deep within the ship's midsection. Then came the circular structures. On deck, analysts identified two large circular steel features aligned over the central hull. Their placement and spacing were not random. But here is where precision matters, and where the story gets complicated. No one released a schematic labeled Reactor here. No engineer came forward. No procurement document surfaced in the first wave of reporting. What analysts had was geometry, and geometry has patterns. Naval architecture follows engineering logic. Reactor compartments require shielding. Shielding creates volume. Volume dictates structural geometry, and geometry leaves fingerprints, if you know what to look for. Observers compared the Dalian layout to known schematics of American nuclear carrier reactor arrangements. The proportions tracked, the spacing tracked, even the placement relative to catapult infrastructure tracked. But here's the key. None of this was confirmation. The war zone described it as strong evidence, not proof. And that distinction matters, because a wrong conclusion does not just embarrass an analyst. It misframes an entire strategic debate. There are alternative explanations. Electromagnetic catapults require enormous electrical generation. Integrated electric propulsion demands large machinery compartments. High-energy radar systems push power requirements further. A large internal block could still, in theory, house advanced conventional systems. And China had not officially said nuclear. No ceremony, no press release, no doctrinal statement, just steel, and questions no one could yet answer with certainty. If this were nuclear, why the silence? If it were not nuclear, why does the internal architecture so closely resemble one? Analysts divided. One camp argued the structural similarities were too precise to ignore. The other warned that incomplete imagery is exactly where intelligence failures begin. The nuclear debate, at this stage, was still circumstantial. Large hull, reactor-like geometry, no official confirmation. Then analysts revisited something they had largely set aside. And when they looked again, the story changed completely. Up to this point, everything rested on interpretation. Satellite imagery, structural geometry, comparisons to American carriers, strong indicators, but still indirect, still deniable. Then analysts revisited something reported months earlier, and suddenly it looked entirely different. Near Leshan, in Sichuan province, at a facility known as Base 909, a land-based prototype reactor had been identified through satellite imagery and procurement documentation. Initial reporting placed it in the civilian nuclear development category, a research program, something to monitor, but not necessarily alarming. That framing did not survive a second look. AP reporting, supported by research from the Middlebury Institute, linked the project to China's Nuclear Power Institute. Significant on its own, but then came the connection that changed everything. The same documentation linked the project to the 701 Institute, the same 701 Institute responsible for aircraft carrier design. The project was codenamed Longwei, not a civilian power program. Documents indicated a pressurized water reactor, designed specifically for large surface warships. Pause on that. A reactor, designed for large surface warships, built by the same institute that designs China's carriers, tested at a land-based facility, years before the hull in Dalian reached its current scale. That sequence does not describe speculation. It describes a program. A land-based prototype serves one purpose: validation. Engineers test shielding, test heat exchange systems, test turbine integration, test safety protocols, all before placing a reactor inside a hull. You do not build a land-based naval reactor unless you intend to put one in a ship. Naval nuclear propulsion is not something you improvise at sea. You validate it on land first, then you build the hull around it. And here's what that validation means for the timeline. If the reactor program predates visible hull construction, and the documentation suggests it does, then the propulsion decision was made before the ship was assembled, before the modules appeared in satellite imagery, before the public debate even began. The hull in Dalian is not China testing whether it can build a nuclear carrier. It is the delivery vehicle for a reactor program that was already running, quietly, inland, for years, while analysts were still debating whether it was possible. That is the moment that genuinely shocked the analyst community. Not the imagery, not the hull size. The realization that the enabling technology was already operational in prototype form before the public argument about feasibility had even concluded. Analysts were no longer asking, can China build a naval reactor? They were asking, is this hull the first deployment of one they already proved out years ago? The shock was not sudden progress. It was delayed recognition. The reactor came first. The carrier followed. The world noticed last. To understand why the reactor matters, look at what came just before this ship. November 2025. China commissions Fujian, the largest conventionally powered warship China had ever built. Electromagnetic catapults, roughly 80,000 plus tons. A genuine leap from everything before it. and immediately, its limits became visible. Electromagnetic catapults draw massive bursts of power in short intervals. Conventional propulsion can supply that, but it costs. Every radar sweep competes with propulsion. Fuel must be replenished more often. Every hour at high operational tempo is an hour closer to a resupply window the adversary can plan around. Conventional carriers have predictable logistics rhythms, and predictable logistics rhythms are exploitable. Now scale that problem to 105,000 tons, 90 to 100 aircraft, J-35 stealth fighters, KJ-600 airborne early warning aircraft, unmanned systems, advanced radar arrays, expanded electronic warfare capacity. The power demand is not additive. It compounds. At that scale, conventional power does not just stretch. It becomes the ceiling. And a ceiling is a strategic vulnerability, one an adversary can exploit, schedule around, and wait out. A nuclear carrier removes that vulnerability entirely. Months at sea instead of weeks. No refueling interruptions. No trade-offs between propulsion and weapons systems. The power budget expands. The adversary's planning window closes. The reactor does not just change endurance. It changes what the ship can do with that endurance. It changes which operations become possible. It changes how long a commander can maintain pressure before logistics forces a decision. A nuclear carrier in the Taiwan Strait does not raise the stakes of a single engagement. It changes the timeline pressure on every regional actor. Japan's defense planners face a carrier that does not rotate out on a predictable schedule. Taiwan's command structures face sustained presence, not episodic pressure. U.S. Indo-Pacific positioning must account for a threat without a predictable resupply window. Endurance changes options. Options change decisions. Decisions change outcomes. That chain starts at the reactor. Building the hardware is only one layer. Because a ship entering the water does not automatically win the competition. That is where the conversation moves from engineering to geopolitics. China now operates 3 carriers: Liaoning, Shandong, and Fujian. Dual carrier exercises in the Western Pacific, expanding air wings, accelerating operational tempo. All 3 rely on conventional propulsion. All 3 face the same ceiling. A nuclear carrier breaks that ceiling permanently. Endurance shifts from weeks to months. Presence becomes less dependent on supply ships. The logistics tail shrinks. Who loses first? For Taiwan, a carrier that remains in theater longer changes deterrence at every level of the conflict ladder. For Japan, it reshapes the threat calculus in the East China Sea. For Southeast Asian states, it alters the South China Sea balance, where presence, not just power, determines influence. For India, it changes the Indian Ocean equation in ways New Delhi has not yet fully modeled publicly. Staying power is geopolitical power, and nuclear propulsion is the engine of staying power. And here's what that means for the regional order. The actors who built deterrent strategies around the assumption that Chinese carrier presence would be time-limited, that a deployment window would close, that a refueling cycle would create an opening, those strategies are now structurally outdated. Not eventually, now. But analysts are equally clear about what does not change overnight. The United States has operated nuclear carriers for decades. Carrier aviation culture, deck handling efficiency, integrated strike group coordination, combat experience across multiple conflicts. That institutional depth is built over generations, not procurement cycles. China's carrier doctrine is still maturing. Training pipelines are expanding. Overseas basing remains limited. Logistics chains are still being built. Hardware can be built in years. Mastery takes decades. That gap is real, and it still matters. The hull suggests structural parity in scale. The reactor prototype suggests propulsion parity in development. But operational parity is not automatic, and it is not imminent. What is changing is the trajectory. And trajectory is what keeps naval planners awake. Not the capability a rival has today, but the capability it is building toward. Together, the evidence describes a program crossing a threshold, not approaching one. Because propulsion is not a cosmetic upgrade. It is a generational commitment. By this point, the debate is no longer about a blurry satellite image. It is about convergence. A hull over 1,050 feet under construction at Dalian. Displacement estimates firmly in supercarrier territory. Internal structural volumes consistent with reactor compartment geometry. A land-based naval reactor prototype at Base 909, linked through procurement records to the 701 Institute, the same institute that designs China's carriers. Public confirmation of a 4th carrier under construction, with no technical bottlenecks acknowledged. None of those elements alone prove the ship is nuclear-powered. Together, they form a coherent pattern. In defense analysis, coherence matters more than headlines. China is building its first nuclear-powered aircraft carrier, and it has been building toward this moment for longer than most analysts publicly acknowledged. That does not erase American naval dominance. But something irreversible changes. For decades, nuclear supercarriers were a closed club, a capability so complex that no near-peer competitor operated one. If Type 004 is nuclear-powered, that exclusivity ends. Not gradually, not partially. The club has a new member, and membership is permanent. The hull in Dalian did not appear out of nowhere. It emerged from a sequence. Prototype reactor, electromagnetic catapult carrier, expanded shipyard capacity, official confirmation of a fourth hull. The surprise was not speed. It was alignment. The reactor was ready. The hull followed. The world is still catching up. For 70 years, the ability to sustain a nuclear-powered floating airbase anywhere on Earth was an American sentence. As of Dalian, it is not anymore.